And today I'm going to be demonstrating 5 Burp Suite labs. The first one I'm going to be looking at is the SQL injection, the union attack, and determining the number of columns returned by the query. So in this demonstration, I'm going to be using Burp Suite Community Edition, and also I'm going to also you would need an account into Burp Suite to be able to do this lab. So let's go ahead and get started. Let me share my screen. So Burp Suite, you need to log in first, but let's first go ahead and describe our first task here. So the goal here is to determine the number of columns returned by the query of an SQL injection using the union query string. And this attack, this vulnerability is going to be first we have to determine what the vulnerabilities are and what the categories are. So according to this description, the product category filter is the one that is vulnerable to SQL injection attack. And so when we are able to get into the lab, and we will be able to demonstrate that the SQL injection attack, we can demonstrate the SQL injection attack by submitting the union query to the back end. So let's go ahead and get started. Let's get into the lab. To be able to get into the lab, we'll have to sign in. So once you're able to sign in, this is what you're going to see. And as you see over here, this lab is not solved. If the lab is solved, it's going to see, it tells that it was going to change from not solved to solved, and going to say congratulations here. So the goal is to get to the solved button here. And as you can see, this section lists a whole bunch of items and then their prices. So if we want to filter it out, we can click on this and it brings us a smaller list, right? I'll click on this and it brings us a smaller list. So this is the button that are vulnerable to SQL injection that we're going to try to exploit. And to be able to exploit that, let's go ahead and get our Burp Suite 10-hour intercept on, and when I turn it on, every request that is coming through is going to be intercepted until I have done anything that I want to do with it. So let's go ahead and turn it on. So now our intercept is on. Then let's go ahead and use the food and drink tab here. So once you click it, this is going to keep pending until the request here has been allowed to go through. All right, so this is our request here. So I'm going to send this request to a repeater. So it's been sent to a repeater, and what a repeater does is that it helps you to be able to to be able to modify request multiple times and change it as how you want it and submit it and get the response right from the same repeater, instead of navigating somewhere else. So now we have captured what we need, so we can turn this intercept off and let the request go through successfully. Now it went through, and then we got a short list here. So what we're going to try to do here is go to the repeater, and as we can see, we have this repeater here is the same request that we have submitted. We have a get request, and then we have the URL, and there's this category here that we're going to try to use to the query for the category. That's what we're going to use to um, combine another table and retrieve and determine how many columns it has. And the reason how we could be able to do that is that for a union, for you to be able to successfully execute a union query, those two tables should have the same columns for you to be able to successfully retrieve a query, a union query. And as you can see here, this is our output from this when we click on the filter here. So we definitely know that the output here has at least two columns here, because this is the item column and there's the price column. So that table can definitely have two. It has for sure two columns. So let's try, so we can use that to start to see if we can find out how many columns it does have. So if it has exactly two, then you should be able to get a response, 200 response from the server. So now let's try to add a union query to this. So union, and of course it has to be encoded. So let's add select, and we're going to add a null, right? So that's the first one, the first column, right? So for example, if we supposed to just run this, click on send, the response here should give us internal server error, which is an indication that the union has more than, the table has more than one column. So we can add the second column to it and check that and see. We send that again. So we still have the server internal error. So now let's try to add one more to it. Now we get a 200 response from the server, which is telling us that the table has three columns. And so now that we're able to get 200 response, if we go back to our lab test, now it has changed to solved. Congratulations, you have solved the lab, because we were able to determine to know how many columns this table has, right? So that concludes the first lab test. So now let's look at the cross-site scripting attack. That one has two. We're going to be doing two of the attack: stored cross-site scripting and reflected cross-site scripting. So for our stored cross-site scripting, the end goal is that we want to be able to submit an alert, a script to this comment section or functionality of the application here, and it should be able to store it in the database in such a way that anybody who comes back and view the blog should be able to see that particular alert message. Um, so the end goal is that we want to be able to submit a successful script to the database, right? So, and cross-site scripting is a way of actually carving a script with a lot of executable or functions or code that you want or script that you want to execute and to do anything that you want it to do, right? So because it's a script, so script can do a whole lot of different things that you wanted to commands that you wanted to execute. So um, the goal here is to be able to get it to the database, install the script in the database in such a way that anybody that makes a call of that particular role or of that particular um, entry in the database should be able to trigger this command to execute. So let's look at this lab together. So now we have our lab open here, and you see that we have, view post here. We have different posts. We have different posts. So let's just use the first post here. And when you go into the post, that is where you will be able to enter in your comment and then your details, and you will be able to submit it to your comment to the database, and it should be able to come back here and display your comment on the screen, right? Just like how we already have a comment by Carl, book nourish the soul. We want to also add our comment onto this page. So the comment that we want to add is just a script that we want executed, and in this particular case is just an alert, and in the alert we're just going to say you just got hacked, right? And we're going to close our script tag. Yeah, so that is the comment we want to post, and this has to be, because this stores data into the database, it should be able to store it script in the database if it is vulnerable to stored cross-site scripting. So we put our name in there, we put our email in there, and then we put our website. Now we were successfully able to save our script to the database. So it says that um, the lab has been solved, right? So that is how you were able to test this lab, that it is vulnerable to stored cross-site scripting, because it successfully stored our um, it successfully stored our script that we want to execute. And as you try to go to the post, it shows that you have just been hacked, right? That is the message that we have stored in the database, right? So as you can see, before it brought me to here. As a matter of fact, let's try that again and go to our different posts. See, nothing happens for that particular post. But if we go into that particular post that we had, the database that we have modified, it should bring out the alert, say, hey, you just got hacked, right? So that is how we solve this this lab. So now the other one is the cross-site scripting, the reflected cross-site scripting. And the reflected cross-site scripting basically is a way of um, being able to execute your script, but your script is not going to be persistent in the database, but it's going to still linger around in your application. And is a way of an attacker being able to just get his or her script executed without any footprint in the database, right? So if your application is um, if your application is still vulnerable to cross-site scripting. So let's go ahead and test out the demonstrate that as well. So with the reflected cross-site scripting, um, with a reflected cross-site scripting, the end goal is that we want to be able to submit an alert also to the back end, but it's not going to be persistent. But instead, we're going to have our script execute, and it's going to pop up an alert on the screen for us to see. But we're going to utilize the feature of the application, which is the search function that's supposed to go and do a search and return you the result. So let's quickly look at the lab together. So now we are into the lab, and we're going to utilize this. We're going to utilize this search box here, and the same as we did, we want to let the application, the search box here, execute our script for us. Yeah, so we're just going to create an alert, and then we close our script tag here and says that you have been hacked. Right. So once we click on this, we should be able to see a pop-up, which indicates that we have. Oh, look like we did not see that. Let's see what happened. So let's see what happened. Oh, we did not close our message here. So let's try that again. Now we get a message pop up saying that you have been hacked again. Right. So this is the reflected cross-site scripting. Now our lab has been solved, and it says congratulations, you done so well by demonstrating the reflected cross-site scripting attack. Um, so now the other lab that we will want to demonstrate is the cross-site request forgery. And cross-site request forgery is a vulnerability, can be demonstrated if your application is vulnerable to cross-site scripting or cross-site. But with cross-site request forgery, is just a way of identifying the client and the server and establishing the communication between them in such a way that there is no somebody cannot, man in the middle cannot take up the and try to be the client and talk to the server, right? So that is what we're going to try to demonstrate here. And the first one we're going to look at is uh, cross-site request forgery, where there is no remediation at all in the application. There's no form of remediation at all. So in this cross-site request for jump with no defenses at all. So the end goal is that we want to be able to change the email address of a viewer. So once we change that email address of a viewer, we should be able to create HTML code that we can use to save it onto the exploit server, and that should be able to submit the request to the server, and she'll be able to still change the email address of the user as well. So let's get started. So with this lab, this is the exploit server, and we're going to get into this account by using Werner and Peter as a password. So WIENER, and then the password is PETER as the user. So we are able to get into the user's account, Werner's account, and this is his email, right? But we want to change his email account uh, to let's say test@test.com. Right. So let's use that account. So we're going to try to change this user's email from this to this. So let's go ahead and change this. We submitted the request and it went through successfully. So if we go back to the account here, the user's um, email has changed to test@test.com. Right. So now if we go to Burp Suite here and we look at the HTTP history here, we should be able to find a request that will that we just did that we changed the email. So if you can see the URL say my account changed my email, and the response said it got a 302 response, and then the body parameters is the email. This is the test email that we just changed to. So this is how we changed it. So now we're going to try to use these same information and change the email uh, and see what happens. So let's go to um, here and let's go to the exploit server side. And in this body part, we're going to actually um, type I've already typed it, so I'm going to copy and paste, but we're going to create a HTML payload, which we're going to use to store it and use it to change um, the email. So let me copy and put it here. So this is the HTML payload that I have typed it in here, written in here. So this is going to be a post method, and this is where I got it from, the post method. And if you right click and copy URL, that is where I got the URL from. And of course, the parameters that we're trying to target here is this parameter, the email, and then the value is this. So now let's try and change this one to, let's say, a@test.com, right? And then we're going to say store it. So now we see that we were successfully able to change the email address, and then the lab says it has been stored, right? So we have successfully changed the email address to a@test.com, right? So if we're supposed to go back here and look for that request again that we just did, right here, that is the test that we just did. We were able to get a 200 response where we actually stored the information and it was successful, right? So and the same thing as this. So that is how we that's how we solve uh, the other lab, the cross-site request forgery. So we were able um, to modify the email or without having to through a hidden field, right? Through a hidden field, we're able to modify the request without the user knowing anything about it, right? So now let's go ahead and look at the last cross-site request forgery. Um, that one is a little bit different because that this one has a way of preventing what we just did. But what is what is happening in here is that instead of using a different way of generating validating the cross-site request forgery, it is using the request method. The request method is the one that is being used to validate the cross-site request forgery token that has been generated, which allows the client and the server to communicate without a man-in-the-middle attack. Right. Um, so let's go ahead and so the goal here is also to change the email address of a user by still using the email address functionality, and also by exploiting the cross-site request forgery, by bypassing the token, the secret token that has been generated and put in the request. Right. So let's go ahead and get into the lab. So now we are in the lab, and in the lab, we have my account again. So we're going to try and go to my account again. We're going to log in um, as winner with Peter as password here. And once we're able to log in here, we're going to change winner's password again. So now let's do b at bbest.com, right? So this is the email address we want to change it to. So we go ahead and update the winner's email. And if we go back to the account, we should be able to see that it has successfully changed the request here, right? So now let's go back to our request here, and we look at, okay, so it did this. It was able to change it by using the request. And if you can see here, the request has a cross-site request forgery, right? Has a cross-site request forgery token. This is a secret token that has been generated and placed here that the server can use to identify the client and said, okay, yeah, we have already been communicating over by using this token. So now we're going to try and see if we can bypass this. So let's send this to a repeater. And now we have our request in a repeater, right? So if we try to send this request, let's send this request here, we get a 302 say that I was able to submit the request. Now let's try to modify this token here and send it. Now we have what? A bad request, right? Invalid CRF token, right? So without this token, you will not be able to what? um, um, be able to modify the email at the back end, right? So now how can we do this, right? And as I have mentioned earlier, this request is the server is validating this request based on this method right here. So let's try and change this method here and see if we are able to achieve anything, right? So let's go ahead and, because I lost the token here, so let's go ahead and send this again to the repeater. So now I have the exact token here. So let me change this request method, right? Change request method. So now it has changed the request method. Now it has changed it from post to get, and then see how it has reconstructed it for me here. So we're going to try and then use this to bypass the CRF token, right? So if we send this here, we get a 302, right? Because it still has the token, right? But if we were supposed to take away or modify this token here, right, then we are able to what, successfully submit the request and still get what, the 302, right? Saying it was able to change it. So if we should change this to, let's say, a at dast.com and submit this request, and if it's successful here, now if we go here, let's go home here, my account. Now the email has changed successfully, right? But yet still, our lab is not resolved, right? So now let's go ahead and then go to the exploit server, and I already also have already typed in the information here, so I'll just copy and paste the request here. But so go to the exploit server, and in the exploit server, I'm going to paste this here, and this time I'm going to change this from post to get, because that is the way that we can change this without needing the cross-site request forgery request. So we go in here, and then this should all be the same. Now let's try to change this to d at my best.com, right? And then we submit it. Yeah. Okay, looks like something went wrong. Let's try to see what went wrong here. Okay, so I think I made a mistake here with the URL, so I went back and copied this URL again. And then pasted it here in this URL. And now let me change this to, let's say, dog at best.com. So now let's try and install this. Now it says that congratulations, we have solved the lab, right? So that is how we were able to. And now if we were supposed to look at the account here again, okay, so the lab is solved, right? But it will not let us go back. But yeah, it should have let us go back and see what we have changed it to now, but it wouldn't let us. But yeah, we have successfully changed this submitted request to the server, and changed the email address to dog@best.com. So that is how we solve the lab. So we started off with SQL injection, where we find out how many the number of columns that a table has. And also we did the stored cross-site scripting where we submitted a script into the comment here, and then it popped up. But if you wanted to go ahead and wipe all the database or anything of that crazy stuff, we could have put it in a script, and then it would have done that for us if it is if the application allows that. Then we went ahead and did a reflected where we searched through the search button with another script, and then it also popped up. And then we went through the cross-site request forgery where we tested when where there is no remediation of cross-site request forgery here, and we're able to change the test, the email address of Weiner. And also we also did the second cross-site request forgery where there is cross-site request forgery token that has been generated and established between the client, but it was not validated. It was validating on the request method. So once we change it to get, we were able to bypass the token that is being generated and using to validate the request, and we were able to successfully change the email address of this of the user. Right. So that ends the demonstration. Thank you for your time, and we'll see you another time. Thank you.